Okay, so I'm going to record this and I'm going to post it. So if you want to go back and watch it later, you can. So today we're looking at, we have a new unit today on matter and transformations. I did grade your quizzes from yesterday. I think two people may have turned it in after I'd graded it, which is fine. They're not going to lose any points. I was just, it was due by the end of the day yesterday, but I got it. I was grading them earlier in the day, so it's fine. So I will grade the rest of those and have the scores for you shortly after class today. Okay. If you do have any questions or comments or concerns on the quiz, please do let me know. If there's something you're not sure, you don't understand why you got it wrong or something like that, just let me know and we can talk about it. Okay. You can stick around after class if you want to ask those questions. Okay, today we're going to be, again, like I said, we're starting a new unit on matter and changes. So the first thing I want to do is I want to look at the success criteria. So usually I create success criteria for every unit. I did for the first unit. I forgot to, I think I put them up there, but I don't know if I went over them with you guys. But this is a work in progress. I haven't taught ninth grade science in a little while, so I just made this up and still work. I'll still be kind of refining it and doing things to it as we move through the unit. But basically, this tells you everything we're going to cover in this unit. So first, we're going to talk about classification of matter, like what is matter. We'll talk about atoms very, very briefly. The next unit is really on atoms. So this unit, we're only really talking very, very briefly talking about what an atom is. That's made of protons, neutrons, electrons. And then we're going to explain the number of protons defines a specific type of element. And then we're going to classify and identify matter as pure substance or mixture. We're going to actually do all of that today. And then we're also going to talk about today physical and chemical properties of matter. So define chemical properties as well as this is, again, a work in progress. I missed some things here. And physical properties, chemical properties, physical changes, chemical changes, talk about those things. We're going to kind of talk about that today. So pretty much 1 and 2 we're going to talk about today and get that kind of done. And then on the other side here, we're going to talk about this thing called kinetic molecular theory and how it relates to temperature. And then we're going to convert between temperature scales. We're going to look at the 3 phases of matter in terms of molecular motion, kinetic energy. Then we're going to look at physical changes in matter. So we're going to look at phase diagrams. What happens when things change phases at a molecular level? We'll talk about phase diagrams, phase change diagrams, which are a little bit different, and all that stuff. We'll talk a little bit about evaporative cooling and the Maxwell-Boltzmann distribution curve. Then finally here, and again, this is a work in progress. These are the scientific practices we're going to be covering, and this is just one I wrote down so far, but we'll be doing other ones as well. So we'll be graphing and identifying independent, dependent variables on graph axes. So we'll be talking about that. I'm doing some practice with that. Again, this is a work in progress. I'll keep updating it throughout the unit. And when we have your final test, it does help to kind of look this over and think, do I know how to do everything on here? Because that's usually what we're covering. Okay, so that's the first thing. The next, we're going to do this lecture on physical, chemical properties and changes. So on matter and physical versus chemical changes, properties and changes, sorry. When we're done going over that, you have 2 worksheets to complete. One COM, so classifications of matter. So this one, let me go over how to do it real quick. So here you have the substance. You're going to identify it as either a pure substance or a mixture. If it's a pure substance, you got to tell me, is it an element or is it a compound? If it's a mixture, you got to tell me, is it homogeneous or heterogeneous? Okay, so that's kind of how it goes here. If it's pure substance, element or compound, mixture, homogeneous or heterogeneous. Each column there. Okay, pretty simple there. I did give you the answers to that there, so do try the best you can to do it on your own, and then check your answers, make sure that they're correct. Okay. The other worksheet you got to do is physical versus chemical changes and properties. So here are, the first thing is just labeling words if they're P or C. And here you can just kind of, I don't care, it doesn't have to be neat or anything, just write like P, C, whatever it is. So P, C, P, C, P, C, whatever. Okay, and I will, you don't have to write out the whole thing, that kind of comes with big pain. So just P or C, P or C. Same thing here, P or C. Same thing here, P or C. And then same thing here, P or C. Okay, they're just like a little bit different. That's why they're kind of separated. I adapted this from another worksheet where there was other things in between to do, but I just made it simpler. P or C, P or C. Okay. And I'll have the answers to that shortly. I did have the answers to it, but it was really sloppy. Well, there was other things on it, so I have to just alter it, and then I'll post the answers up to that as well as soon as possible. Okay, so that's what we got to do today. So let's start this talking about matter and transformations here. Okay. Sorry, it's not very pretty, but it gets the job done here. I don't have any pretty pictures on this first slide here. Let's talk about first thing. Well, what is matter? And yeah, this is kind of a lot of information right here too. Not that pretty, but we're going to kind of go through these things again a little bit. Well, what is matter? No. Matter technically is anything that has volume and mass. Anything that has volume and mass. Volume is basically the space an object occupies, and mass is an object's resistance to change and acceleration. Whew. Well, we also define it as the amount of matter something is made of. It's very closely related to weight. But you can think of anything that takes energy to move, anything that requires, if you want to change its velocity, change where it is currently, change its velocity in any direction, you need energy to move it. You need force. You need force. So anything that requires force to move is considered mass. So if it has mass and it has volume, it is considered matter. Now, one of the little fibs that we tell you guys, and I'm sure you've heard it before in your other science courses, is that all matter is made of the building block called atoms. Well, yeah, that's sort of true. That's sort of true. As far as we're going to be concerning ourselves with in this course, all the matter we are going to be talking about is made of atoms. Okay, at least in this unit. But if you think about it, atoms are made of 3 subatomic particles. So sub meaning smaller than atomic particles, so smaller than an atom. They're made of protons, neutrons, and electrons. Okay, and those protons, neutrons, and electrons are also matter. They are matter. They have mass. They have volume. Okay, so they technically are matter. So it's a little bit of a fib when we say that all matter is made of building blocks called atoms. Okay, but as far as we're concerned, we're only considering matter as something that's made of atoms. Okay. every type of atom is classified or organized by the number of protons in the nucleus. So the number of protons in the nucleus tells us the type of element it is. So every atom with 1 proton is called hydrogen. Every element with 2 protons is called helium. Every atom with 3 protons is called lithium. Okay, now the number of neutrons and electrons can change without changing the name of the atom or the element. Okay? But if protons change, the name of the element changes. We're going to discuss atoms, elements, subatomic particles, protons, neutrons, electrons, a lot more in depth in the next unit. Okay, in this unit, we're only concerned about things that are atoms are larger, right? Atoms are larger. Right? Atoms are combinations of atoms. Okay. Oh wait, I want to do this disclaimer first. So here's that disclaimer that I talked about. Students like you learn that all matter is made of atoms. Atoms are considered the smallest building blocks of all matter, but that's not really the case. Atoms are composed of protons, neutrons, electrons, which all have mass and occupy space, therefore are matter themselves. Those subatomic particles are also made of smaller particles called quarks. Quarks are made of even smaller particles, all of which have mass and volume. Okay? Now, anything really smaller than a proton, neutron, electron is really the realm of quantum physics and quantum chemistry, and we don't really talk about that. We're not talking about that in this course, so it's not really a big deal. And in this course, we're only going to be discussing matter in terms of atoms and how they combine. Okay, actually, the famous equation, E equals mc squared, right? You all know that equation, right? E equals mc squared. That actually relates mass and energy together. So we can actually say that energy is matter as well. So it kind of is a almost like a philosophical discussion to ask what is matter. It's like more of a philosophical discussion because we don't really know for sure. We don't have the science to understand exactly what matter is. But as far as we're concerned, we'll make it simple. Matter is it's something that is something that's made of atoms, right? Something that's made of atoms. Okay. Now again, like I said, atoms are the smallest building blocks of matter. They have unique properties. Each atom has unique properties, and they're organized by the number of protons in the nucleus. So 1 proton, like I said, is hydrogen. 6 protons here is carbon. 8 protons is oxygen. These are the periodic table. I'm sure you all have heard the periodic table before. Okay, all the elements are organized in the periodic table by their number of protons. Okay, so number of protons really determine the chemical and physical properties of an element. Okay, and that's why we organize it by number of protons. So it's a really, really important thing to understand that atoms are organized by number of protons. Number of protons define the element. It's going to become really important in the next unit, not so much in this unit. But I'm a chemistry guy. I was majoring in chemistry, so it's something that I really emphasize. Okay, so going back to that disclaimer here. So this is generally how we classify matter. It's not the most perfect classification system. Everything in science, I always tell people, like, yes, understand these organizations and understand, I want you to really like know these things, but I really want you to know them, like understand why they are organized the way they are and be able to argue and, because none of these things are perfect. None of these classifications are perfect. Not even when you get like, you'll see as you get more and more into sciences that everything becomes a little bit grayer, right? Like when you're younger, you think everything is black and white, right? Maybe in like elementary school, they tell you like everything is black and white. They tell you things very concretely, okay? But really in science, everything's kind of a gray area. If you really the purpose of these organizations is to understand and predict. Okay, everything is organized so we can understand the world around us and predict what might happen in the future. Okay? So here we have matter, something that occupies space and has mass. Like I said, that is a gray area. Remember we talked about, like I just said, like, yeah, atoms are the smallest parts of matter, but that's what you've been told, but that's not really the case, right? Because protons, neutrons, electrons have mass and occupy space. So, yeah. But anyway, matter can be organized into really two major categories here: pure substance and mixture. A pure substance is a substance that cannot be physically separated. So an element or atom itself cannot be physically separated. You need other than physical means to separate them. So you need like a chemical reaction. Again, this is not totally true. If you ever hear of the Large Hadron Collider, or you hear about them breaking apart atoms. Well, they're actually kind of doing that by physical means. They're just smashing atoms together, and when the atoms smash together, they break apart into different pieces. So that is kind of a physical separation, but it does change the chemical properties. So you can kind of, particle accelerator, yep. So again, understand what they mean and understand, that it's not 100% accurate, perfect. It's not perfect. Okay, so pure substances, as far as we're concerned, matter that cannot be physically separated. So we cannot physically separate it, right? You can't take an element, an atom, and break it apart physically. You can't take a compound, you can't take water and break it apart physically, okay? So in a pure substance, you can have something that's just a single element, okay? Or you can have something that is a compound or a combination of elements, okay? And a very, very simple example is water, H2O. And neither of those things can we really separate physically. We can separate water using electricity, but that's not really considered a physical separation. That requires energy, right? It requires electricity. Okay. And again, really using electricity is kind of a physical separation too, but well, we are changing the chemical makeup of it. We're breaking and making bonds. So basically, pure substance is matter that can not be changed without chemically altering it. Okay? Without changing its chemical structure. All right. On the other side here, we have a mixture. So mixtures can be physically separated. These can be separated by something like filtration. So filtration is when you put it through a piece of paper that has small pores on it, right? It's basically what it is. Distillation. So if you boil off water, whatever's in the water is left behind. Or separated by other physical means, just picking stuff out, right? You can just pick the stuff out of it. Or you can let it settle. Sometimes you can let things settle to the bottom. Okay, there's two types of mixtures. Homogeneous. Homo means the same. Homosexual means same sex. Homo, same. A homogeneous mixture is a mixture that looks the same throughout. You cannot see the individual pieces of it. Okay, something like salt water. You can't see the salt in the water. You can't separate the salt from the water by picking the pieces out. You can't see the little pieces in there. I'm going to give you some other examples too after this. And then heterogeneous is a mixture you can see the different parts. So hetero means different. So heterosexual means different sex. Okay, so we're going to kind of, don't worry if you didn't get that because I'm going to look at it really again. So again, pure substances, matter that cannot be physically separated. So here an element, a single type of atom, such as helium or carbon, nitrogen, oxygen. Okay. And then a compound is when two or more types of atoms chemically combine, and there's no limit. There's no limit to how many atoms can combine. You can have a molecule that's billions and billions of atoms that are together. That's based like DNA. DNA is a molecule that's, billions of molecules, billions of atoms connected together. Okay. Okay. And then again, homogeneous, heterogeneous mixtures. So homogeneous mixture is something that looks the same throughout. Okay. You cannot see the individual particles. A heterogeneous mixture is the one that you can see the different particles with, basically with the naked eye. Okay, so that's classification of matter. Let's talk about physical and chemical properties. So physical properties of matter are ones that can be observed or measured without changing the composition of the matter. Examples are like appearance, texture, color, odor, melting point, boiling point, density, solubility, polarity, malleability, and ductility. Does anyone know what malleability means? Yes. Malleability is the ability to bend. Yes. Or really, it's if you can hit it with a hammer and instead of breaking into pieces, it will mold. I always think malleability, moldability. But yes, ability to bend, to change shape, to be pounded into other shapes. How about ductility? Anyone know what ductility is? So ductility means the ability to turn it into wires. Okay. The ability to turn it into wires. Now, in Hawaii, we don't really have, most people don't have central air conditioning or central heating in their house. But in that type of system, there's ducts. They're basically tubes that go throughout your house to send the warm and cold air throughout your house. So a duct, you've also probably heard of like an aqueduct. An aqueduct, aqua means water, duct, it's a water passageway. It's a water passageway. A duct is basically a passageway for something to flow through. Okay, so ductility means that we can take something and turn it into a passageway. Well, what flows through wires? Electricity. Okay, so basically, ductility means can you take the substance and turn it into a passageway? So ductility is the ability to turn metal into wires, or the ability to turn something into a wire. Okay, most metals are ductile. Okay, so ductility is the ability to turn into wires, and because that word duct means a passageway. And in this case, a passageway for electricity. Okay. Now, chemical properties. Chemical properties are how substances will react with other substances. Examples are like flammability, toxicity, acidity, reactivity, heat of combustion. So how much energy it will release when it burns. Will it burn? Will it burn? Will it catch on fire? Is it toxic? Can you eat it? Will it cause harm? Acidity, will it react with a base? Will it corrode something? Reactivity, will it react with other things? It basically answers the question, how is this compound likely to react? I personally like to think, is it a chemical property? Is it a chemical change? If the answer is yes, easy. If the answer is no, then it's a physical one. I don't even think about what physical changes are. I think chemical. I only think in terms of chemical changes. Is it a chemical change? If it's not a chemical change, then it must be a physical one. Because chemical changes, there's less words to remember. There's less properties to remember. Whereas there's physical changes and physical properties. There's so many of them that I just remember the chemical ones, and then if it's not chemical, then it must be physical. Okay, so difference between physical and chemical changes. So physical changes do not change the composition of the substance. Okay, the substance stays the same. Okay, it can change phases of matter, but if it's changing phase of matter, then usually if you heat it or cool it, it'll go back to its original form, right? Usually physical changes, people say that they're reversible, right? I don't like to use that. I don't like to say that because if you break a piece of glass, it's kind of hard to reverse that. I mean, you could melt it and turn it back into glass, I guess, but it's hard to do. But if you break a table into a million pieces, that's a physical change, but it's really hard to reverse that, right? And chemical changes actually sometimes are really easily reversed. Okay, sometimes you can easily reverse a chemical change. If you take water and you separate it into hydrogen and oxygen using electrolysis, it's really easy to turn it back. You just light it on fire and it turns back into water. Okay, so I don't like saying that physical changes are reversible and chemical changes are not, because a lot of chemical changes are easily reversible and some physical changes cannot be reversed, right? So really just think a physical change, you're only changing the physical part of it. It's staying the same element, staying the same compound. There's no chemical change occurring. There's no new substance being formed, okay? In a chemical change, a new substance is being formed. Chemical bonds are being broken and or made in a chemical change, okay? And I like to think in terms of chemical changes, okay? Because chemical changes have distinct, very, very distinct indicators that a chemical change has occurred. When we do chemical reactions, we're going to do chemical reactions in this class, and we're going to talk about these indicators, okay? And we're gonna, if we ever get back in the classroom, we'll do a lab where we see all these indicators, all right? It's like one of the most popular labs we do because we get to burn stuff, but we'll see. Hopefully we get back into class. So I just like to remember all the indicators of a chemical change, and then if it's not a chemical change, it's a physical one, right? So here are the indicators of a chemical change. Change in color. Anytime you have a change in color, guarantee chemical change. Change in color, chemical change. Okay. Production of light. So like if something catches on fire or explode, like I don't want to say explodes per se, but something catches on fire or gives off light, that is going to be a chemical change. Now, if you heat something and it starts glowing, like metal, and it starts glowing, that is not necessarily a chemical change. You're just heating it up till it's like melting. Okay. One of the things is if the light is produced and you can't reverse whatever happened to it. So like if you heat metal and it gets red hot and then it cools down, it goes back to its normal state. That's not a chemical change. But if you heat something, get it really, really hot and it starts glowing and then it doesn't go back to its normal state, then you've done a chemical change. All right. Temperature change without heating or cooling. So if you're not putting heat in or you're not cooling it down and a temperature state change starts happening, that is an indication of a chemical change. So you mix two chemicals together and they start getting hot. You mix two liquids together and they start getting hot. You're not adding heat to it. That is an indicator of a chemical change. If you mix two things together and they all of a sudden get cold, that is an indicator of a chemical change. The next one is a production of gas. So if you produce a gas, that's almost always an example of a chemical change. You mix two things together and a gas is produced. Now, the one exception here is if you're boiling something, right? If you heat something up to a boil and you're just turning it from a liquid to a gas, okay, then that is not a chemical change. One of the ways you can see if that's the case is if you boil it and then it condenses back to a liquid, then you know it's not a chemical change. Okay, if you boil it or you're heating it and the bubbles form and then you cool it again and nothing shows up, then you had a chemical change. Number 5 is the formation of a precipitate. So precipitate is when you take two liquids together, you mix them together, and all of a sudden a solid forms. You think of precipitation as like rain, right? Precipitation, rain. You have gas turning into a liquid. That's kind of the idea here, but you have instead two liquids coming together and they form a solid. Okay, two liquids together forming a solid. That is a precipitate. And then the last one is change in smell or taste. So if there's an odor that's produced, so kind of like a production of a gas, or if you're eating something and it tastes different, that could indicate a chemical change. Okay, again, so when I think of physical versus chemical, I think of these 6 indicators here. If one of these 6 indicators has occurred, it's probably a chemical change. If it's not, then it's a physical one. Okay. I know this is a little bit blurry, but these are some words that indicate physical changes. So if the physical change words are in blue here, and the red ones are the chemical changes. Okay, so if you see those words, that most likely indicates chemical changes for these ones, and then physical for these ones.